Hello everyone, welcome to my channel. Now in this particular tutorial we are going to look on what is exactly an image processing, and then we are going to move on to broader part of it, which is the computer vision, and then we are going to look on to how does computer exactly reads an image, and then we are going to talk about the types of image, and then we are going to look on to OpenCV and some of its basic functionalities. So let's move on with what exactly is an image processing. So if we talk about the image processing, it's about you can call it as an extension of signal processing, right? So basically in signal processing we deal with a one-dimensional signal, but if we talk about image, it's actually a two-dimensional signal. So you have like in an image you have like a width, right, and a height. So we are generally talking about a two-dimensional signal in the case of image. So what exactly is image processing then? So it's actually a method to perform certain operations on your image, right? To get a particular information from it, or you can either extract some information from it, or you can enhance your image. For example, if you have used the app which is Snapchat, actually they apply some filter to your face, right? So you get sort of enhanced image from that particular app. So that is an example of image processing. So basically in image processing, the input is an image and output is also an image, or you can call it as output is a form of enhanced image, or you can also get some information from it. Now we talk about computer vision. So I hope that most of you have already used Facebook. So in Facebook what happens is that whenever you upload a group photo, and there is a feature in the Facebook called as auto tagging. So the reason behind that particular phenomenon is the computer vision itself. So computer vision is used for many applications like facial recognition, facial detection, right, and many other applications as well. So what exactly is a computer vision then? So it's, you can call it as a subset of artificial intelligence. It automates the task of humans, right, in the case of visual perception. So basically that is what a computer vision is. So it's kind of broader part of image processing. So you can see in this case that like it has done the object detection. For example, this one is the traffic light there, this one is a car. So basically in computer vision, the input is an image and the output is an information. So that is a basic difference between a computer vision and image processing. In image processing, the output was image itself, but in computer vision the input is the image and then you extract some information out from it. So that is what we call as computer vision. So now we are going to talk about how does a computer reads an image. So if we see this particular image, it really looks a normal image, right? But that is not how a computer reads it. It actually reads it in the form of a NumPy array, or you can call it as a matrix. So this is actually how the image looks like. So it's actually a bunch of pixels there. These mathematical values are called as pixels, which is actually the smallest unit of an image, and that is what image is made up of, the small values of pixels. So particularly this is a array, or you can call it as a matrix of numbers, and that is how a computer reads an image. It converts that into numbers, and if we perform certain mathematical operations on these numbers, at that time the image processing, or you can call it as a computer vision, is further analyzed from this. So now let's talk about the types of images. So there are basically two types of images. The number one is the grayscale image and the other one is the color image. So basically if you talk about this one, it's actually a grayscale image. So you have heard that we can also call it as a black and white image, right? So that is what exactly a grayscale image means. So it's actually a single channel image. It's actually a single channel image, right? So basically it depends upon your dark pixels and white pixels, or you can call it as a bright one and a dark one. So the number would vary between 0 and 1. So the grayscale images, the NumPy values, or you can call it the matrix numbers, are only 0 and 1. But if we see the images, most of them are like color images. So they are actually 3 channel images. So the 3 channels are red, green and blue, RGB. Now when we talk about the channels in case of OpenCV, it actually uses the form of B, G and R. Okay, so we are going to learn about that in our upcoming sessions. Just for today, so that is the two types of images. Number one is the grayscale image, which is actually black and white, and the second one is the color image, which we see normally. It is actually 3 channel, namely red, green and blue. These are the channel consisting in color image. Now we are going to talk about what exactly is OpenCV. So OpenCV is actually a platform developed for developers or engineers to perform certain image processing, or you can call it as an advanced image processing and computer vision process, right? So that is what OpenCV offers you. You can call it as a library or a module for performing computer vision tasks and automating the image processing tasks. So it is actually cross-platform. It was developed back by Intel, and you can use it in various languages such as C, C++, and it is also open source, so we can use it obviously for free. So with the help of OpenCV, you can do a lot of things with the images, and now we directly move on to what are the things we can do with OpenCV. So before that, let me just tell you how do we uh, for which software are we going to use, right? So we're actually going to use this particular distribution for image processing tools. So you need to firstly go on and then use the Anaconda distribution. So Anaconda distribution actually provides you with a lot of packages for scientific computing. So you can actually download this using this website. You just can download it, and then you will get a lot of softwares regarding the data science and for scientific computing and all. So basically you can download it from here itself. And for the image processing technique, we are going to use this interface called as Spider. Okay, so we are going to use Spider as our interface for image processing tasks. So now let's move on that how do we perform image processing. So this actually is the interface of Spider, and that's the version. You can see that it's Python 3.9. Now you call this as your workspace. You call this area as a workspace. This is actually the console, and this is your, you can like whatever variables you are putting here, it actually shows up here. And this is the value of plots. So whenever you are plotting any sort of figures, at that time you can plot there. You can import files from here. So for example, if you create any sort of files, you can just import the files directly from this menu. So this is what a basic Spider interface looks like. And you can just zoom your code. So let's say I'm writing this, so you can just zoom it using Control and plus. So if you see this, you can zoom this. You can also zoom this particular console using Control plus, right? So now it looks fine maybe. Okay, so now let's look on our code itself, that how do we use OpenCV to perform certain analysis or operations on an image. So let me actually move on with my code. So first line is that we need to import our library, right? The first and most important thing is that we need to import our library. Basically we import the OpenCV, but in Python we call it as CV2. So we're going to import CV2, right? We are going to import CV2. So what is CV2? It's actually OpenCV, so right, it's OpenCV, which is used as CV2 in Python. Now once you have imported the CV2, it's that your CV2 has been imported, right? Before that, I forget to tell you one thing, is that you need to actually firstly install this library. Maybe it's like if you use some other platforms, you will need to actually install it. So for that, you just need to go into the prompt, right? You just need to, if you can type here, you can see the Anaconda prompt, right? You just need to go into Anaconda prompt, and then you just need to type this particular thing as pip install OpenCV and Python. If you type this, your OpenCV gets installed, and then you are ready to go, right? So you just need to type your pip install OpenCV. Now I need to actually import my image, right? So for example, in which image am I going to perform my operation? So for that, I will create a variable called as image1, and in this image I will store the path of the image which I am going to read. So for that, you will have cv2.imread, which will read your image, and in this parameter you will need to give the location of your image. Okay, so let's say that I have this particular image, okay, a particular image of a random person out there. Okay, so this is what my image looks like. So you need to copy the path of it. So how do you do that? I'll just tell you simple trick. This is not a trick, it's actually followed. So you need to Control C this, copy this, just paste it down there, right? You'll just need to copy paste it down there. I just need to give you a double slash so that it doesn't throw you an error. So once you have copied the path there, now what we want to do is that we want to actually give the name of an image, right? So the name of my image is person. If you see the name of my image is person, so you will need to type the name of an image again type it like this, and then give your person dot, sorry, it's like this, and then give your person dot jpg. Okay, so now you do this much of thing. This is actually the path of your image, and this is actually the name of your image. So this is how you perform or you read the image, right, using OpenCV. So firstly you need to import the library, and then you will need to show the path of the image. Now I wanted to tell you that as I previously told, that the image is nothing but a bunch of matrix, right? So if I print this image, it's gonna give me a whole bunch of numbers there. So you can see there is a lot of arrays, right? It's a lot of number arrays. So you can see there the multiple arrays there. You can also see in this particular frame, it's actually an array of unsigned integer of 8, and it has a size of this. So it's actually, I told you, it's RGB, but in case of OpenCV or in Python it's BGR. So this is actually the channel, 3-channel image, right? Since it was a color image, and this is a value, this is the matrix of your image, right? So what we do is that we perform operations in this particular matrix, right, in this particular matrix. So this is how you actually print your image. Now let's say that I want to see my image, right? So how do I do that? So there is a very simple code for that. I just need to show my, so for that I am using imshow, right? And then in this index I need to give my Windows name, right? Windows name. So you can keep it any, let's say I keep Windows name as original, right? And then you give the name of your image in which you have stored there. So I am stored my image in the variable image1, and I do that. Well, doing this doesn't work. You need to actually type two most important things. So you need to write your wait key. I will tell you what wait key does, and then you destroy all windows. Destroy all windows means once you have done seeing your image, it will actually clear out your window. Okay, so yeah, that is what okay, so it's actually cv2. So destroy all windows, right? So once you have viewed the image, it will actually cancel out or destroy the windows. Okay, regarding wait key, I will tell you just in a few moments. So let's try to run this and see if our image has been opened. Okay, there you go, our image is finally opened, right? And I have passed here the parameter is 0. So when I passed a parameter as 0, so whenever I type any numbers or any sort of keyboard, if I type a space, it will disappear, right? So the importance of cv2.waitKey is that it shows the image up to a particular time. So let's say that I type here 3000. So it is going to run my image up to 3000 milliseconds, or you can call it as 3 seconds. So let's count it. So 1, 2, 3, and it disappears, right? Yep. So that is what the wait key does. It's actually used for showing your image up to a certain frame of time. So I hope you are clear with this code now. So I will just once again explain this. I have just imported my OpenCV library. So it's actually written as cv2 in Python, and then I have given a variable which will store my image, and then I need to use imread for reading my image, right? And then this is my particular location of my image, right? And this is how I import the path of my image, and for showing the image I need to use the imshow and give the Windows name original. So if you see here, your Windows name is there, it's original, right? So you can give it any, doesn't really matter. A wait key is actually for initializing the time up to which your image remains, and destroy all windows will actually destroy your windows once you have done seeing the image. Okay, so that is what you need to do. So let's say the other operation is that, let's say now I want to actually resize my image. So you can see the image is pretty large, right? Let's say that I want to resize my image. So how do I do that? So just, it's really simple. You just need to type one line of code again. Image1 equal to cv2 dot resize like this, and then you resize the image. You give the name of the image like this, image1. You need to resize image1, and then inside this you give the width and height. Okay, so let's say that I want a width and height of, okay, let's say 700 comma 600. So what I have done is that I have just used the resize function to actually resize my image1, and then I give the value of width and height. Okay, let me also type in the comment there. So it's actually the width and height. Now let's try to run this. You can see the windows has somewhat reduced, right? So it goes up to 3000. So let's make it like 0, and you can see the image clearly now. So it's actually the Windows height has reduced, so your width and height has been reduced, right? So that is how you perform the resize. So you can give it a value of anything. You can just give it like 1280 and 720. It will again modify your image, right? Modify the width and height of image. You can call it as a dimension of image. So there you go. Yeah, so it has been a bit larger than before, right? Okay, so now we have done the resize of image. Now we actually look on that how do we actually convert an image into a grayscale image, right? This is actually a color image. If you see this image, you can see it as a color image, right? What if I want to I want to convert my image into grayscale? So how do I do that? Let me just show you. If in the path of the image itself, you will need to pass the parameter as 1. So as I told you, the 1 represents for brighter pixels. So 1 will actually give you the color image, right? 1 will give you a color image. So you can see that it's a color image, right? What if I want to pass the grayscale, or you can call it as a black and white image? I just type here as 0. I just type here 0. Now this is going to give you a black and white image. So you can see this, it has changed the color, and it is given you a black and white, or you can call it as a grayscale image, right? So this is how you actually convert an image into a grayscale 1. Now let's type here -1. Okay, so -1 actually increases the saturation, increases the color saturation. So now if you run this, it's actually has increased a bit. You don't notice it, but yeah, it actually increases the color saturation of an image. So that is what we do for today. Thank you for watching.